Hello dear students, this is resistance loop. A circular loop of radius 15 centimeter is made so that the radius of the loop is given 15 centimeter. This is radius of loop, that is 15 centimeter, that is equal to 15 over 100, that is 0.15 meter, and the cross sectional area has a diameter is given. Cross section area has dimension 3 millimeter, so the diameter D is 3 mm, that equal to, so radius of the cross section is equal to 3 over 2, that is equal to 1.5 into 10 to the power minus 3 meter. Okay, so what is mean by radius and what is mean by this? Basically we have a circular loop, and for the complete circular loop this is circumference. So the so that the radius is given, so if radius is given we can find the circumference by using this capital R. And for this small r, basically this is the wire has the cross section. The cross section of the wire is the area of cross section. In order to find the area of cross section we use this small r. Small r is used for the area of the cross section, and capital R is used to find the length of this wire, this loop. Okay, 12 volt battery is attached here. The potential is 12 volt, battery is at 12 volt. Okay, and this wire is the same type. The wire is made from the same material, and the switch S is used to connect the point C and D. Okay, so we have to find, actually in this problem we have to find the total current I through the battery when the switch S is open. So when switch S is open, so that we have to find the current I. Okay, so in main goal in this problem is to find the current, and the given information is the radius of circle 15 centimeter, cross sectional diameter is 3 millimeter, and the resistivity of wire is 1.5 10 to the minus 4 meter, and the potential difference is 12 volt. Okay, so this is the basic equivalent resistance diagram. You can see that here we have all 4 wires that are attached, because you know that there are 4 wires, 1 2 3 and 4. There are 4 wires, so each wire is attached. This AC is the resistance between AC is represented by this. For suppose this is R1, CB resistance is R2, and AD resistance is R3, and DB resistance is R4, and CD, the switch S is opened here. Okay, now we see that how to solve this problem. First of all, we solve for the resistance. We use the formula for resistance. So R is equal to rho L over A, resistance R. So we find resistance that is equal to rho L over A. So the formula for resistance 1.5, resistivity, value of resistivity is 1.5 10 power minus 4 ohm meter, and length of the wire. So what about the length? Actually you know that the there are 2 lengths here. You know that one is upper half circumference from A to B point. We have length half of that length A to B, that is equal to, so length is half length is 2 pi r circumference divided by 2, because this is half of the circumference from A to B. From A to B the length is 2 pi r circumference divided by 2, that is equal to, length is equal to 2 pi r divided by 2. So we use pi r. So length is equal to pi r divided by the area. So area of the cross section is, you know that the area of the cross section is pi small r square, and small r is given in the question, that is 3.1. for small r is given in the question, that is 1.5 into 10 to the power minus 3 meter. So 3.14, or you can write pi 1.5 into 10 to the power minus 3 meter and square. You know the formula is pi r square, area of the cross section. So we solve this. See, this r is the resistance, this r is the resistivity, so this r is resistance, this r is radius, and we put the values 1.5 into 10 to the power minus 4 multiply 3.14, and the radius of the wire, radius of the circular loop is 15 centimeter, that is 0.15 meter, divided by 3.14 into 1.5 10 power minus 3 meter square. So so 3.14 will be cancelled, and so value of the R is resistance is 10 ohm. 10 ohm. As you know that the uh, 10 ohm is parallel with the other 10 ohm, so we can write as 10 ohm. So R equivalent resistance is equal to 1 over R equivalent equal to 1 over 10 plus 1 over 10. That makes 10, and 10 plus 10, that is equal to 20 over 10. 1 over equivalent 10, 1 plus 1 2, sorry, 1 plus 1, that gives us 2 over 2 over 10, that gives us 5. So R equivalent is equal to 10 over 2, that is equal to 5 ohm. So the equivalent resistance is 5 ohm. So if equivalent resistance is 5 ohm, then we can find the current I, that is equal to V over R. So potential is 12 volt divided by 5 ohm is the resistance, that gives us 2.4 ohm. So the current flowing through the circuit is 2.4 ohm. This is what we need to find. Okay, now when the switch S is closed, okay, now when the switch S is closed, again this switch is closed, so that we can solve this by using the same formula. But now in this case, our length will be half 4 times, because you know that this is a circle from A to C, C to B, B to D, the lengths are same, D to A. All length, given that AC is equal to CB is equal to BD is equal to DA, so all lengths are equal. So if we have a complete circle, that is circumference, so the length L is equal to 2 pi r complete circle. So here length is actually, we know that the portion AC, length of AC, that is equal to 2 pi r over 4, that is equal to pi r over 2. So the length is the same formula, we use the same formula for the length is, now length is pi r over 2, mean pi r over 2. So we use formula R is equal to rho L over A, L A C or any other. So we have our A area. So resistivity is given 1.5 10 to minus 4, length AC is pi r over 2 divided by 3 pi r square. R is small, r is actually the area, 1.5 into 10 to the power minus 3 meter square. And we solve, we get answer. In this case, we get answer 5 ohm. So resistance is 5 ohm. So if this is 5 ohm, this is also 5 ohm, this is also 5 ohm, this is also 5 ohm. Okay, so we solve this 10 ohm and the 10 ohm. The modified circle is 10 ohm, 10 ohm, and the 10 ohm, because you know that these two are in series, so we have this kind of no 10 ohm, and we know to find the R equivalent of the 10 ohm plus 1 1 over R equivalent equal to 1 over 10 plus 1 over 10. It will give us 10, 1 plus 1 2 over 10, 1 over R equivalent, that is equal to R equivalent is equal to 5 ohm. Now if we have the resistance 5 ohm, so the current I is equal to V over R equivalent. So V is 5 ohm, sorry, V is 12 volt and resistance is 5 ohm. Now 12 by 5, the same current 2.4 ampere flows through the circuit, the same current. Okay, thank you. So A and B both has the same answer, the 2.4 ampere. Okay, the only difference is that in this case we have the length AB. We know that the length A to B, we need to have the length from A to B, so that the length A to B is divided into two portions, AC plus CB, but our total length from A to B is L is equal to 2 pi r over 2, half circumference upper portion. And this, for this length we have the again half circumference, that is 2 pi r over 2. But for the other case, when the switch is closed, so we have this length AC. that is 2 pi r over 4, and this length is also 2 pi over 4, this length is also 2 pi over 4, this length is also 2 pi over 4. So we only you solve for length, all other values are the same, and then we solve for resistance, then we solve for the current. Okay, thank you.